Okay, today we're going to be looking at exponential equations, and an exponential equation is an equation that has a variable as an exponent or part of the exponent. And my statement here says for a greater than 0 and a not equal to 1, if a to the x equals a to the y, then x equals y. And just like most of the things in college algebra, that statement is a little bit more confusing than it really is when we start to apply it. If I have 3 to the x equals 3 to the 5th power, but these powers are the same, the bases are the same, so the exponents have to be the same. So this exponent x has to equal this exponent 5. Now, one thing I do want to point out here, and this is important, is that a cannot be 1. Because if I have 1 to the 3rd power and 1 to the 5th power, they're both equal, right? 1 to the 3rd power is 1, 1 to the 5th power is 1, but I see the exponents are not equal. So my exponents do not have to be equal. So that means that I can't use this method when I have x as one of my exponents up here. Okay, so we're going to be looking at solving exponential equations. And the first thing that we need to do is to write the expression on each side of the equal sign as a single power with the same base. Set the exponents equal to each other, and then solve the equation. Now, we're going to start off with some very simple problems here, and some problems that you could probably just do in your head. If I have 3 to the x power equals 9, then I know that x has to be 2 because 3 squared is 9. But if I wanted to write this out, showing all my work, really what you're doing here is you're realizing that 9 is 3 squared, and that these two things have to be equal to each other, so x equals 2. That's how I could work it out showing my work. Now, if I have a problem that's a little bit more complicated, then I may not be able to do this in my head. Well, what I could do is use my calculator and take 6 to the 2nd power, 6 to the 3rd power, 6 to the 4th power, and keep going until I find one that's going to give me 216. And another way to do this, instead of having to put all of that into my calculator, is I could put this in as a function, go to your y equals button and type in 6 to the x power, and then look at the table that goes along with that. And you can see that this is going to give you 6 to the 3rd power as being 216. So your x value is 3. All right, now let's get into something that is a little bit more interesting. 2 to the 2x plus 1 power equals 8. I want to try to write 8 with the same base that I have over here. I want to write 8 as 2 to some power. Well, I can do that. 8 is 2 to the 3rd power. So now I have these two powers that are the same. I can set these exponents equal to each other and solve. So let me do this. So I have 2x plus 1 equals 3. So 2x equals 2, x equals 1. And you can always go back and check this. Put 1 in place of 2. 2 times 1 is 2. And 2 plus 1 is 3. 2 to the 3rd power is 8. Now let's look at one that is a little bit more involved here. I'm going to have 3 to the 3x plus 5 power equals 27 to the 4x minus 8 power. So I could take 27 and write it as 3 to some power. Remember, I want these bases to be the same. So the left-hand side of my equation is still going to be 3 to the 3x plus 5. 27, I want to write as 3 to the 3rd power, and then that is to the 4x minus 8 power. So now I use my laws of exponents, use the power rule. So I multiply this power of 3 times 4x minus 8, and I get 12x minus 24. Now I have the two sides equal to each other with the same base. So my exponents have to be equal to each other. 3x plus 5 equals 12x minus 24. Get rid of the 3x, add the 24. So x is 29 ninths. All right, my next problem, rolling on down here. I have 8 to the 3x minus 1 power equals 16. Now I cannot write 16 is 8 to some power if that power has to be an integer. But I can write 8 and 16 both with a base of 2. So that's what I'm going to do. I'm going to have to take this 8 and write it as 2 cubed. And I'm going to write 16 as 2 to the 4th power. Now I can use my power rule here, multiply these exponents, and get 9x minus 3. Now the powers are equal, so I set the exponents equal to each other and solve. 9x equals 7, so x equals 7 ninths. All right, problem 6. We have 25 to the x minus 2 power equals 125. Should pause the video right here and see if you can solve that. Okay, the answer there is 7/2. Be sure you know how to show all your work on that. And then we're going to go on to another problem here. 4 to the 2x plus 3 power equals 8 to the 4x minus 9 power. And again, I want the same bases on both sides. 4 and 8 both can be written with a base of 2. So that's where I'm going to start. I'm going to write 4 is 2 squared. And I'm going to write 8 as 2 cubed. So multiplying my two exponents here, according to my power rule, I have 4x plus 6. Don't forget to distribute this 2. 2 times 2x and 2 times 3. And here I'm going to have 12x minus 27. So now I can set my exponents equal to each other and solve. So I get 6 equals 8x minus 27, and add 27 both sides. That's supposed to be 12. Here we go. 33 equals 8x, and x will be 33 eighths. Okay, next problem here. 25 to the 6x plus 2 power equals 125 to the 2x minus 1 power. You should pause the video and try to do this problem on your own, and then come back and check your answer. Okay, your answer there is x equals negative 7/6. What number was that? Okay, problem number 9. This problem, I have a fraction, and it's easy to see that my base is going to be 7 because I know that 7 squared is 49. But because it's down in the denominator, there's a couple things here that I need to realize. First of all, I need to realize that I'm going to be needing to show my work thoroughly, and noting that I also have to be using negative exponents. 49 is 7 squared. Now what I'm going to do is use my rules for negative exponents only backwards. Normally I'm given a negative exponent and I'm asked to simplify my expression by getting rid of the negative exponent. But here what I want to do is to get this out of the bottom part of the fraction. So I write this with a negative exponent. That is 7 to the negative 2 power. So now I've got 2 powers. The bases are the same, so the exponents are the same. So x is negative 2. And my next problem is also going to be dealing with fractions. I have 2/5 to the x power. Be sure that 2/5 is in parentheses, so it won't look like it's just 2 to the x power. And here I have 125 over 8. Well, I know that 5 cubed is 125. I know that 2 cubed is 8. The thing is that these are sort of in the wrong spot, kind of like upside down. There's a couple different ways I can go about doing this problem. What I want to do first of all is to write 125 as 5 cubed. I'm going to write 8 as 2 cubed, because that's kind of the first thing that jumps out at me. Now, like I said, these are in the wrong spot. The 2 should be up top, and the 5 needs to be down in the bottom for it to match up with this left-hand side. So if I used negative exponents, I could switch these around. 2 to the negative 3 power over 5 to the negative 3 power. Well, that is going to be the same as 2/5 in parentheses to the negative 3 power. So x is negative 3. And then the last problem I want to do here is 10 to the x equals 0.001. Now, I like to say this as 0.001, but if you ask elementary school teachers what that is, then they will tell you that that is 1/1000th. Elementary school teachers are very good about saying these numbers correctly. And when you say it correctly, you realize that you could write it as a fraction, 1/1000th. And now I can see that this denominator I can write as 10 cubed, and then I can use my laws of negative exponents and write that as 10 to the negative 3 power. So x is negative 3.